Here's an example with a hot air balloon. A man and a woman standing 3.6 miles apart spot a hot air balloon in the sky between them at the same time. If the angle of elevation from the man to the balloon is 26 degrees, and the angle of elevation from the woman to the balloon is 42, find the altitude of the balloon to the nearest foot. So what's going to be helpful on this one is to draw what they're talking about. So let's have a good little picture here. So I'm going to draw something like that, and then we get this balloon. See, the woman's is okay. So I'll put the balloon maybe about right there. Hey, that's not bad. Let me try again. Here's my balloon. All right, and so from the man, so I'll go up with the man here and go like that, and then from the woman like that. All right, so we're gonna put the man here and the woman here over here, and they are 3.6 miles apart, and it's between them. That's why I put it between them. At the same time, angle of elevation from the man to the balloon is 26 degrees. The angle of elevation means from flat up, and for the woman that's 42. So her angle is 42 degrees. That means the balloon's a little closer to her. See how I put her a little closer to the balloon? Because her angle's a little bigger. See how it means that? You can just see it spatially. Find the altitude of the balloon to the nearest foot. The altitude, well, what's the altitude? That means straight down, doesn't it? That's altitude. Call it H for height, right? Altitude is height. That's what altitude means, right? You know that. It means height. And how do you measure your height? Do you go diagonally down to the ground? No, you'd be ready for the NBA, is always my joke, right? Height has to go straight down to the ground, doesn't it? So that's altitude. That's what they want us to find, the height. Okay, so how are we going to find the height of the balloon? This is not an easy question. Well, notice when you bring that height, you make a couple of little bitty right triangles, don't you? Couple of little bitty right triangles. But the problem is we don't know anything else about the sides of the triangle. So what I'm going to do, what I think would probably be easiest would be to find one of the other sides first. It doesn't really matter which one. So let me get rid of the height for now. We'll put it back later. And I'm just going to say, hey, here's my game plan. I want to find this side, call it X. How am I going to find it? By the law of sines. Because this big entire triangle is not a right triangle, is it? It's not a right triangle. So let me write a note over here. It's not a right triangle. So we cannot use SOHCAHTOA. Right, you can only use SOHCAHTOA. That H in the SOHCAHTOA stands for hypotenuse, which means across from the right angle. So you can only use SOHCAHTOA when you have a right triangle. So instead we're going to do law of sines. And for law of sines, you've got to have a side and the angle across. Whoop, that's not it. The angle and the side. So I want to find X. And I have this angle, but then I need another side and angle. This angle I can find with that side. That's what I'm going to do. So the first thing I'm going to do, step number one, top angle. The top angle in this triangle must be 180 minus the other two added up, right? Because every triangle holds 180 degrees. We've seen that a few times. So, use my calculator. I'm getting 112 degrees. So that top angle must be, this one, must be 112 degrees. Now, why is that so great? Now I can use the law of sines to find X. Why? Because now I have these two. I have an angle and a side combo, don't I? So I can say, 3.6 over the sine of 112 degrees must equal these two, right? Which is X over the sine of 26 degrees. Do you see that? These two. Right? That's what the law of sines says. Side over angle across from it equals side over angle across from it when you're doing the sine of those angles. Law of sines. That's what it says. So I can use that to solve for x. So diagonal. So 3.6 sine 26 degrees is x. Sine 112. How do you finish solving there for the x? Divide by the sine of 112. And boom, boom. So x equals, using my calculator here, I'm getting 1.70207. Choose a bunch of, you always use a lot of digits when you're not to the end yet. So that's x. 1 point, so let me write that over here. 1.70207. Okay, now why did I do all that? That's not what I want, right? Why did I do all that work to get x? Because now, let me get rid of this 112. I don't care about it anymore. Now, I can come in here and say, okay, this is what I've been gunning for all along, right? I want the height. Well, that's a right angle there, isn't it? Right? Because that's what height does, comes straight down to the ground. So if I look over here at this triangle here, just this side right here, look what I've got. I've got a right triangle, just that half of it. And I got the x, so I have enough information to solve for h. That's why I did all that work to find h, because now this side is opposite, this side's adjacent, and this side's hypotenuse, isn't it? Now I can use SOHCAHTOA, because that little bitty highlighted triangle is a right triangle. So I can say, I'd like to maybe do it right over here where you can see it and still see the picture. The sine of 42 degrees is opposite h, right? Remember SOHCAHTOA, sine is opposite over hypotenuse. Opposite h over hypotenuse, 1.70207. That's how I can solve for h. So let's put this guy over 1, diagonal. H times 1 equals 1.70207 sine of 42 degrees. H times 1 is just h. Use your calculator times the sine of 42 degrees. I'm getting 1.1389. I don't know. Oh, nearest foot. Oh my goodness, really? So it's just 1 foot. Is that foot or miles? What is that? Miles. Yeah, it says find the altitude of the balloon to the nearest. Oh, to the nearest foot. Oh, I didn't notice that. Oh my goodness, we got to change units here. Okay, because everything else was miles, right? 3.6 miles. Oh, this is an evil problem. We got to change units. That's okay. We'll work it out here. So, so this is miles right now. So I'm going to write down a bunch of digits. 1.1389. 10238 miles. So I got to change that to feet. How do you do that? You take 1.1389 miles, and then it's in 1 mile. You put miles down here because you want miles to cancel out. Is 5,280 feet. Did you ever learn about changing units? You set them up so they'll cancel. You want miles to cancel, so put it down below. 1 mile equals 5,280 feet. So basically multiply that number by 5,280 feet. And I'm getting 6013.4. So that rounds to 6013 feet. 6013 feet. So that balloon is 6013 feet high. That was a little tricky twist right at the end. So there we go. We used law of sines at first to find the x over here, and then we were able to do a right triangle on the right side with SOHCAHTOA. Sine is opposite over hypotenuse. Solve for h. got our h in miles, and then we had to multiply by 5,280 feet in every mile to change it to feet and round to the nearest foot.